Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Welcome back. Problem 9.10. The statement of problem is that knowing that beam AB is an S8 by 18.4 rolled shaped and W0 is equal to 4 kips per foot, length is equal to 9 foot, modulus of elasticity is 29 into 10 raised to the power 6 psi. Determine A, the slope at point A, and B part is deflection at C. So you can see that this is a short flange beam. The cross section is given. Now this beam is a simply supported beam with pin support at A and a roller support at B, and there is a uniformly increasing load and then decreasing load is given, and the value of W0 is 4 kips per foot per length. So you have to determine the deflection slope at point A and deflection at point C. So let's start with the given data. So in given data we have been given that it is S8 by 18.4 rolled shape there, where W0 is equal to 4 kips per foot. Length is given, that is 9 foot or feet. E is modulus of elasticity, that is 29 into 10 raised to the power 6 psi. Here you have to find the first part is slope at A, so theta A, clear, and B part is that you have to find deflection at point C. You have to find deflection as well. So let's start with the solution. So first of all, for solving this problem, you have to find the reaction force at point A, RA, and reaction force at B, which is RB. So we will draw the free body diagram of this beam AB. So this is the free body diagram of this beam AB. This is the reaction force RA. There is a reaction force at point B, which is known as RB. Now you can see this is a uniformly increasing load. It starts from point A and the maximum is at point C, and then it decreases, so it forms a triangular load. So in order to convert this load into concentrated load, we will apply this load will be, I will explain, this load will be equal to, you can see this is a triangular, clear, so it will be equal to 1 over 2 W0 into L by 2, clear, this is one term, plus this load, triangular load, and this is again a triangular load, so it will be 1 over 2 into W0 into L by 2. Why I have taken this term? Because you can see area of this triangle is equal to 1 over 2 base into perpendicular. So perpendicular is W0 and base is L by 2. So again, if you add this load, the addition of these two will give you W0 L over 2. So we have converted this uniformly increasing and then decreasing load into a concentrated load. Now you can see by this is point C, this is a point A, and this is point B. So symmetry bond, we will use symmetry boundary at point C. So use symmetry boundary at point C. We know that the load is symmetrical, so this RA and RB will be equal to, RA is equal to RB, and it will be equal to this load divided by 2. So W0 into L divided by 2 into 1 over 2. So it will be equal to 1 over 4 W naught into L. Clear? Now we have reaction forces RA and RB. We will move to find the moment equation. Why moment equation? Because as we know that from equation of elastic curve or slope, EI into d square y over dx square is equal to moment. Clear? So we will find the moment for this beam. As we are interested at point A and C, so we will section the beam at this point. So if we section the beam, that this is point A, this is the reaction force at point A, let the section distance is x. Clear? So let this distance is x, which I have mentioned. So if you cut the beam at this section, so definitely there will be a shear force V and there will be a bending moment M, and this load will be like this. Okay, so this scenario is for x is greater than 0 or greater or equal to 0 and less or equal to L by 2, because we have seen that x is greater than 0 and it is less or equal to L by 2. So here, as this load was W naught, clear? So for this x distance, it will be W, this W new load will be equal to W into half of W. This load will be equal to W naught into X distance over total L. Clear? Okay. So this W will be equal to W naught into X of this total distance. This total distance is L by 2. Clear? So it will be equal to 1 over, sorry, it will be equal to 2 times 2 W naught into X over L. Now this W is 2 W naught X over L, because here W naught was for this L by 2, clear? So this W will be equal to W naught into X part of L by 2. So X part of L by 2, which is equal to 2 W naught L over L. Clear? I hope it is clear. So for finding the moment equation, I will let this point is J. So we will write sum of all moment about point J is equal to 0 and taking the counterclockwise as positive. Again, you can see that there is a reaction force and perpendicular distance is X, so it will be RA into X, and it is producing clockwise, so that's why it is taken as negative. Clear? Now there is a moment, reaction moment at this point J, so again this is counterclockwise, so it will be positive. Now due to this load W, it will, if I convert it into concentrated load, so it will be like this. So this is RA, clear, and it will be acting over X over 3 at a distance of X over 3. Clear? Total is, for example, X, so it will be acting at a distance of X over 3, and this load will be, as it is triangular, so converting it into a point load, it will be this load into 1 over 2 multiplied by this load, which is 2 W naught X over L multiplied by base, and base is X. Clear? So this load will become equal to W naught, 2 will cancel, then it will be equal to W naught X square over L. Clear? Now you can see this load point load W naught x square over L is also producing a counterclockwise rotation. So it will be positive and it will be equal to W naught x square over L, and perpendicular distance is x by 3. Their sum must be equal to 0. So from this we can get moment, and this moment will be equal to RA into x minus W naught x cube over 3L. Now you have RA value, which is 1 over 4 W naught into L. So it will be equal to W naught L over 4 multiplied by x minus W naught x cube over 3L. I hope it is clear. So this moment, if I take W naught over 4 as common, W naught over L is common. If I take W naught over L, so from this term we have taken W naught as common. So again here it will be only x, and L is also taken, so it will be L square. So L square divided by 4. Clear? When you multiply it, it will be W naught L square x over 4L, and LL will cancel, it will give you the same value. Similarly here you can see that W naught is taken as common, so it will be only x cube over 3. Clear? So this is the moment equation which will be used for finding the slope and deflection, and that will be put in this equation A. Clear? Let this is equation B and this is equation A. Clear? So put equation B in equation A, we get EI into d square y over dx square is equal to W naught over L into L square x over 4 minus x cube over 3. So for finding the slope, we will integrate this equation. Integrating it, we will get EI into dy by dx is equal to, the constant will remain outside, it will be W naught over L. Clear? And integration of this term will give you L square x square over 8. Clear? And this term will give you, this will be x4 divided by 4 multiplied by 3, which is equal to 12. Clear? So I will also let this is equation number C. Clear? Again integrating it. We will get EI into y is equal to W naught over L will be the same, and it will be L square x cube over 24, and this term will be equal to x5 over 60. One thing is that I have forgotten to write is that when you take integration of this equation, so integrating it for the first time, when you integrate it, you will get this plus there is constant of integration, and if you again integrate it, you will get this plus C1x plus C2. Clear? Let this is equation number C and this is equation number D. Now this C1 and C2 are unknown constant, and we will use boundary condition in order to find this C1 and C2. So for boundary condition, you can see both ends are fixed. So at point A, x is equal to 0, so deflection will be equal to 0, and at point B at x is equal to L, again y is equal to 0. So we will use these two boundary condition in order to find C1 and C2. So first let me also write this boundary condition. First boundary condition is that at x is equal to 0, y is equal to 0. So put it in equation D. One more thing is that if you put this equation in this, clear, so you will have these values will become 0, clear. Okay, yes, if you put this value, y will be 0, this term will be 0, this will be 0, this will be 0, so it means C2 will be equal to 0. The second boundary condition which we will use is that since we have been asked to find the deflection at point C, clear, so we will use this, we will not use this boundary condition, we will use this boundary condition that at x is equal to L by 2, theta is equal to 0, because due to this load, this will, I will show you, this will bend like this, clear. So at point C, if you draw a tangent, clear, so slope at point C will be equal to 0, clear. So at x is equal to L by 2, theta C is equal to 0, clear. Okay, so you will put this, so put it in equation C, because this is for slope, clear. So at x is equal to L by 2, you have to put it in this equation, so this term will be 0, clear. So this term, the left side will be 0, and this will be equal to W naught over L into L square over 8, and this x will be L by 2, so L by 2 whole square minus L by 2 whole 4 divided by 12. So again, plus C1. You can see there is a C1. So C1. So when you simplify it, this C1 will be equal to minus 5 over 192 W naught L cube. So we have find out the C1 and C2. C1 is this and C2 is equal to 0. So you can put it in equation C and D. So you will get the equation for slope as well as for deflection. So let's put it. So EI into, I will write draw a line. So EI into dy by dx is equal to W naught over L into L square x square over 8 minus x4 over 12, and C1 is minus 5 over 192 W naught L cube, clear. So when you put the value of C1 and C2 in equation D, so this equation will be equal to EI into Y is equal to W naught over L, W naught over L into L square x cube over 24 minus x5 over 60. C1 is minus 5 over 192 W naught L cube into x plus C2 is 0, so it will be this equation, clear. If you divide EI on both sides, so you will get the equation of elastic curve like this, which is W naught over EI into L, clear, L square x cube over 24 minus x5 over 60 minus 5 over 192 EI into W naught L cube, clear. So if you further simplify this equation, I will write over here, so this y will become equal to W naught over EI into L into 1 over 24 L square x cube x cube minus 1 over 20 1 over 60, because it is 1 over 60 x5 minus 5 over 192 L4 x, clear. Why L4? Here it is L3 because we have taken L as common from this as well, so it will be L4. So if you multiply this with this, it will give you the same value, clear. So this is equation of elastic curve. So again, if you use this is equation of elastic curve, and that is used to find the deflection. You can also, for slope, you have to use this equation, so you have to divide EI on both sides, so you will get the slope equation. Again, if it is difficult to you, you have to do it by yourself. If it is difficult to you, you can also take the derivative of this equation. So this will, if you take the derivative dy by dx, which is equal to slope, and that will be equal to W naught over EI into L. It will be equal to x square, clear. So 3 will be down, so 3 by it will be, this was 1 over 24, I think I have, this is 1 over 24. So again, this will be equal to 3 over 24, which is equal to 1 over 8 L square x square. It will be, again, this will be 5 over 60, and 5 over 60 is equal to 1 over 12. So 1 over 12 into x4, and this will be equal to 5 over 192 L4. So this is equation of slope. Now you have both the equation of elastic curve for finding deflection, equation of slope. You can put the value, you have the given data, that is W naught was given as 4 kips per feet. E is also available, that is equal to 29 into 10 to the power 6 psi. You have the value of L is given, that is 9 feet. Again, all these values are written in given data as well, clear. Only you do not have the I. So for I, as it is given that S 8 by 18.4 roll shape, so you have to go to the book and appendix 4. So when you have S8 by 18.4, so you can check that the moment of inertia I is equal to 57.5 inch 4. So the value of I is 57.4 inch 4. So you have all the values, you can put it in this deflection equation. So when you put the value, so it will be 4 over E is 29 into 10 raised to the power 6 and I is 57.4, clear, and L is 9, clear, and you can put all the other values. I will just put one time, so it is 9 square and X is okay. So you have, it was given in part A, you have to find slope at point A. So at point A, X is equal to 0. So this term will become 0, clear, this term X is equal to 0, and this term, let me check, at, sorry, not slope, again there is a mistake. In first, in part, that is mistake, so we should okay. In part A, it was given to find out the slope at point A, clear, which is at X is equal to 0, clear. So you have this equation that this slope theta so this theta at point A, when you put the value, you have W naught, you have L, you have E, you have I, all the values are here, clear. But remember that this I is in inch power 4, so you have to convert it into feet, because all other, and this E is also modulus of elasticity is also pound per square inch. So either convert this foot into inch or this inch into feet, clear, and put all the values in this. So you will get theta A is equal to minus 6.55 into 10 raised to the power 3 radian, clear. Similarly, in part B, it was asked that you have to find the deflection at point C, and that is equal to X is equal to L by 2. And you can also put the value, or you have W naught, you have E, you have I, you have L, and all the values, clear. Instead of X, you will put L by 2. So do it yourself. So you will get this Y is equal to 18.85 into 10 raised to the power minus 3 feet, or it is equal to 0.226 inch, and that will be minus, clear. So I hope you have learned this video. This is a very simple problem, but your concentration will be required, because if you miss any small term, that will create problem at the end. Thank you for watching.